Hi guys, I've got another pulley question here, slightly challenging. Three particles A, B, C have masses 3m, 2m, 2m respectively. Particle C is attached to particle B. Particle A and B are connected by a light inextensible string which passes over a smooth, light, fixed pulley. The system is held at rest with a string taut and the hanging parts of the string vertical as shown in figure 5. The system is released from rest and A moves upwards. So A move upwards, B and C is going to move downwards. And we know there'll be a tension here, there'll be a tension here, and then the tensions are the same because it's a light string. Inextensible means acceleration is same. Show that the acceleration of A is g over 7. So we're going to form two equations. One is F is equal to ma for B and C on this side for it to go down. So here I've got 4mg altogether and I've got 3mg on this side. So because it's going down, this side is going down, 4mg minus the tension is equal to 4m times the acceleration A. That's the equation for that. The other one is the other side. So tension minus 3mg is equal to 3ma. Because this object is moving up, tension is bigger than the 3mg. So T minus 3mg is equal to 3ma. And I'm going to be adding these two. When I add these two, T and T cancels. 4mg take away 3mg is going to be mg is equal to 7ma. M cancels on both sides. Acceleration is equal to g over 7, which is what we need to prove. Once we've done the acceleration, they're asking for the tension of the string as A essence. Because I know acceleration is g over 7, I'm going to substitute that into one of the equations. So I'm going to substitute in the first equation, 4mg minus t is equal to 4m times the acceleration is g over 7. So that's 4mg over 7 is equal to 4mg minus t. So t is equal to 4mg minus 4mg over 7. 24 mg over 7 is equal to the tension. So easy 7 marks. Just use F is equal to ma. Think about where the object is moving. If it's moving downwards, downward forces is higher than the upward forces. So therefore 4 mg minus t. If it's moving upwards, then you do t minus 3 mg equals to 3 ma. At the instant when A is 0.7 meters above its original position, C separates from B and falls away. In the subsequent motion, A does not reach the pulley. Find the speed of A at the instant when it is 0.7 meters above its original position. So at the instant when A is 0.7 meters above its original position, what does that mean? That means A has already moved 0.7 meters from its original position. That means B and C has also moved 0.7 meters from that position. And this question is about Suva. How much has it moved? 0.7. Who has moved? A has moved, B has moved, C has moved. So 0.7, initial velocity is 0. Final velocity is what we are trying to calculate. Acceleration was g over 7. So v squared is equal to u squared plus 2as. V squared is equal to u squared is 0. 2 times A is g over 7, s is 0.7. So v is equal to square root of 2 times g over 7 times 0.7. So square root of 2 times 9.8 for g, 7 times 0.7, 1.4. And at that point, the velocity of A, the velocity of A is 1.4. And when the object has reached this point, I'm erasing that part, when these two objects have reached that point, the velocity is 1.4. C detaches from B and then separates. But all we need to know is speed of A is the question. I used A. C part is find the acceleration of A at the instant after C separates from B. So I'm going to use F is equal to ma again. Now that C has detached from B, when it's moving down, I would have 2 mg minus the tension. So originally we had it as 4 mg minus tension is equal to 4 ma because those two were there. Now I've got 2 mg minus t is equal to 2 ma. And then for object A, I would have tension minus 3 mg is equal to 3 ma. And let's add both of these, which is minus mg is equal to 5 ma. And therefore, A is equal to cancels, so minus g over 5. And that's the acceleration of A. They're asking the greatest height reached by A above its original position. So if you imagine this object started from here, went here, this detaches, and it doesn't stop there, it keeps going up. Now what's this distance? We know this distance is 0.7. But what's the additional distance that it's going to travel? So for that, I'm going to use suvat. And displacement is the question. Initial velocity is, at that point, we calculated the velocity to be 1.4. So initial velocity is 1.4. Final velocity is 0 because it's going to come to rest at that point. So from here to here is what we are calculating. Acceleration is, we just calculated minus g over 5. So SUVA, v squared is equal to u squared plus 2as. V squared is 0, u squared is 1.4 squared, plus 2 times a is minus g over 5, s is unknown. So 2gs over 5 is equal to 1.4 squared, s is equal to 1.4 squared, times by 5 divided by 2g. Put that in the calculator. 1.4 squared times 5 divided by 2 times 9.8, which is 0.5. But the question was asking height above its original position. Original position is here. From here, if it goes to here, 0.7, and then it goes by 0.5 again. So therefore, in total, it's going to go 0.7 plus 0.5, which is 1.2 meters.